Today we'll be looking at 4 different files to learn how to do summarization using load summarize chain, avoid encoding errors while loading documents, and learn about how to keep track of the tokens that are being used. We will be doing Q&A using stuff, MapReduce, and Map Rerank chain types using VectorDB QA, while using Chroma as the vector store, which is super fast, replaces files. Learn about how to do custom prompts. Learn to use load QA chain, which does the querying outside of the chaining. I'll be putting all the relevant links in the description. OpenAI Embeddings, which is taken care of for us by Chromadb, the Getting Started Guide to Chromadb. Project Gutenberg offers a lot of free books for you to use for your summarization and question answering experiments. We're going to look at summarization, VectorDB question answering, and the question answering with a different method which does the querying outside of the chain, and data augmented generation, which is why we're using stuff, MapReduce, and Map Rerank methods. I'm excited about this. Let's begin. We will actually be looking at 5 files, also the refine method as well. I'd forgotten about that. Anyway, let's begin with a demo of the summarize. I have the space.json file, which is a Wikipedia article about space. So we're going to run summarize, load summarize chain over it using MapReduce while keeping track of the tokens. Let's just run this. We are splitting the text with the text splitter, and the text has been split into 7 chunks. This takes about a second or two. The total process took about 10 seconds, including loading the document, splitting it, and running the station over it. This is the summary, and the total tokens was used was 6,400, which is about 13 cents. We're going to be talking about all these methods, but let's demo the refine method as well, because I've set it to return the refine steps as well. Let's just run this. We have loaded our embeddings because it was in the persistent database anyway. This time we are querying the book, Metamorphosis. It's a weird book. That's why it's called Kafkaesque. Kafka used to write weird books. Anyway, when was the book written? We not only get an answer, which is that was written by Franz Kafka in 1915. We get some information. Also, we get the sources. And we have used a total of 1,426 tokens. Let's begin from scratch, including starting a new environment and pip installing everything. I'll be using Miniconda. I'll put this link in the description. I'm going to create a new environment with conda create -n. I'm going to name the environment summary _ QA with the Python version 3.10. Okay, we have created our environment. To be able to do these in Visual Studio Code, you need to start from a command prompt, and you can initiate your command prompt from terminal by clicking this arrow and selecting the command prompt. I'm going to activate my environment by typing conda activate and the name of the environment. And now we are in the new environment. We will pip install Langchain like this. Next, we will pip install OpenAI like this. Next, we will pip install Chromadb. Takes a minute or two to install. Keep that in mind. It actually takes more than a minute or two. Just got down, but took about 5 minutes. Just keep that in mind. Then we need to pip install tick token. This is important for MapReduce, Refine, and Map Rerank to be able to count the tokens. This is an OpenAI open source library, I believe. Tick token was installed successfully. I'm going to make sure that my Visual Studio Code environment is in that environment, set to that environment by clicking Control-Shift-P, and then by selecting Python select interpreter, and you have to click on the summary _ QA. This is the environment we just set up. If you don't see this, then you have to restart your Visual Studio Code and try again. Make sure you're also in your environment in the command prompt as well. Let's test the summarize chain to make sure everything is working as intended. Okay, this worked. Let's test the MapReduce. Summarize worked and MapReduce worked as well. So these are the requirements: Langchain, OpenAI, Chromadb, tick token. I'll put all the files and including the requirements in Patreon for my Patreon supporters for quick download. I'll put the link in the description. Now we got everything working. Let's review the code, go over it to learn how we can make something like this happen. These are all our necessary imports. Some of them might not be necessary if they're faded out. No worries. You have to define your OpenAI key in your environment variable, user variable as OpenAI API key, or you have to define it here. Then we are defining a large language LM variable to be the OpenAI, which we have imported. We have imported it right here. We are defining the character text splitter as the character text splitter, which we have imported up here. Then comes the next important step. I have this file space.json, which is the Wikipedia article for space. And when you try to load this with open or even with unstructured, you might get some encoding errors. To to the best of my understanding, to avoid all those errors, is to encode and decode it from ASCII. This is just my way of doing it. So this lines of code actually opens it, encodes it in UTF-8, then encodes and decodes it from ASCII, and stores it in a variable space, and then writes that back into the file for future use. Then we are defining our texts as the text splitter, split text space. So we're just dividing it into chunks. We are just printing the length of the texts list, which because text is a list. And then we are defining the docs as a document. And then we are running a quick inline list comprehension for T in texts, If you want to limit the size of your docs for experimental purposes, if you're, for example, if you're using a book or something, you can actually limit it by defining, for example, the first 3 split up texts or something like that. Otherwise, the entire text will be loaded into docs, and you will, when the load summarize chain will summarize all of it, and you will be using a lot of tokens. Then we are defining our chain with the load summarize chain, which we have imported up here. And we had defined our LLM, so we are putting our M as an input to this chain. And also we are defining the chain type as MapReduce. MapReduce method gets all the chunks that are necessary and actually summarizes them first ahead of actually running a final summary. So that's why it's called MapReduce. It's reducing each chunk first, and then relatively speaking, it's doing the chunking process as it goes on. Next, we are running our chain with get OpenAI callback as CB. We have imported get OpenAI callback from Langchain callbacks right here. This is necessary if you want to print your tokens used. We are assigning the result. We're able to the result of the chain that run docs. Docs is what we have defined right here. And then we are printing the result, and we are printing the tokens used with cb.total tokens. And this will summarize your document. Just pay attention that if you didn't put this indexing right here, then you will be actually using the entire document and running a summary over the entire thing. Keep that in mind, please. Next, let's look at the stuff Q&A for using vector DB QA. But before we do that, let's quickly talk about what does it mean, the stuff, map, reduce, refine, and map re-rank. As far as I understand, and please don't quote me on it and read the documentation, but stuffing just stuffs all your, for example, similarity search return chunks into the query to the OpenAI. What MapReduce does is it actually takes those chunks separately and then summarizes them or gets an answer from them separately, and then tries to give you a final answer using that. Refine does the exact same thing, I believe, but it's like linearly. This is why MapReduce can be parallelized versus refine cannot. And map re-rank tries to get an answer from each chunk and then tries to rank it with some confidence. This is pretty cool, actually. We're gonna get there real soon. So let's go over the code for stuff. Stuff requires Chromadb to be pip installed, which we've already done that, and we also have to import it. Our summarize method didn't require Chromadb because we were just sending the chunks immediately to OpenAI and returning the summary like that. Here we are defining a persist directory for Chromadb, so the vector store will be stored locally. You define it as persist directory, here in this case db, and it will create this directory. We will actually start that from scratch as well soon. Since we will be creating a vector store, we are defining our embeddings as OpenAI embeddings, which we have imported up here. Then we are checking if the DB folder already exists in our working folder, because if it doesn't, Chromadb is going to create it. And if it does, then we don't want to spend extra tokens and recreate it. We just want to load from it. So if the persist directory does not exist, then we are actually opening the book.txt, which we have in our working directory, encoding and decoding it, making sure we avoid encoding errors, and then we are assigning to book, and then we are writing it as the book.ASCII.text for future use. Then actually I have some print statements. You can also use unstructured file loader, but I decided to use the text loader, which is much faster, and I am actually loading the book_ASCII.text. And the text loader also comes from Langchain, which I found to be much faster. And if you have just a text document, or if you convert your document to text, I recommend using this maybe over unstructured. And now we are assigning documents to loader.load. This is the normal state of things. You can test your processes with some print statements whenever you like, just to see what shape and size the documents have, and if you want to see the content. Then we are using the character text splitter, which we have imported from Langchain up here, to actually split the text in chunk sizes of 1000 characters with no chunk overlap. This is going to be our text splitter, and then we are assigning our docs as the text splitter split documents, which we have loaded right here. And then you can again test it with a print statement. Then comes the embedding part. We are saying our database is going to be chroma.fromDocuments. We are giving it the documents, which are the split up text that we have defined right here. Embeddings is the OpenAI embeddings, which we have defined right here. And then we are giving it the persist directory as the persist directory, which we have defined in the beginning right here. Then after this, Chromadb will actually create the database and write it under db, such as this. If, however, this folder exists, it will only load it. Loading from Chromadb works like this. You say chroma, persist directory equals persist directory, embedding function equals embeddings. Then we are defining a custom prompt. We are saying the prompt template. This is our custom prompt. You can write whatever you like here, depending on your use case. We are inserting the context here, the question here. Context is our return documents from similarity search from vector store. Then we are asking for an answer here. You can modify any part of this to suit your needs. Then we are defining the prompt with the prompt template, which we have imported up here from Langchain. And then we say template is going to be our prompt template, and input variables are going to be context and the question, as seen right here. Then to apply this to vector DB QA, because we are using vector DB QA for this question answering, you need to define chain type quarks like this, prompt equaling prompt, and then you insert it to vector DB QA by chain type quarks equaling chain type quarks. If you didn't want to use a prompt template, then you can just comment all these out and actually remove the chain type quarks, and you will actually be using the default prompt. I just want to point out that vector DB QA, which we have imported right here from Langchain, actually takes in a vector store argument, and then when we are querying, it actually does the similarity search within the chain. Okay, for example, when we are going to look at MapReduce, we are going to be using load QA chain, and in that case, we are actually going to be doing our querying outside of the chain, and we will actually input those documents which are returned from the similarity search into the chain as the input document. But let's not get ahead of ourselves. The only thing is that vector DB QA takes in the entire vector store, and the querying is handled when you are actually running the query right here, QA query, because we are defining QA as the vector DB QA, which takes in the lam as the argument right here. Chain type is stuff. This can be such as MapReduce, refine, or Map Rerank. Vector store is the DB, which we have defined right here from Chroma, either defined immediately if it didn't exist or loaded it. We say return source documents false. If you set this to be true, then you can actually not only print the result key, but you can also print the source document, so you can actually see which documents were returned from the similarity search. You can examine those. And the chain type quarks is necessary if you're going to use a custom prompt. But if you don't want to use a custom prompt, like I said, you can ignore this part and just remove the chain type quarks if you want to switch back to a default prompt. Then we simply say while true. This is to be able to get continuous queries as input from the user. I define the query as the user input. This is a Python function. Then I assign the result as the chain which processes the query, whatever our question is. Then we are simply printing the results. If we wanted to print the source documents, we would activate this as well. But then we'd have to also return source documents set to be true as well. Now, if we run this, we are actually going to get Chromadb to load the database, but because we already have this, so I'm going to delete it and let it re-embed it all over again. Let's just run and see what happens. I hope we won't get any errors. Chroma log also it prints a log. You can take a look. Okay, as you see, we have created our chunks using our text splitter, and then we are embedding the book as key, no existent DB found, and this was actually super. Right here, we have indexed it all. When we ask when was the book written, we get an answer, so this is working. Now, if we break out of this and run this again, you're going to see that we won't embed the documents this time. We will actually just load them. And this is all happening very fast thanks to Chromadb. And now we can start querying the document. I just want to quickly mention, as you see, we're not keeping track of tokens. If you wanted to keep track of tokens, we would have to import from Langchain callbacks, import get OpenAI callback, and just simply run the line right here after while through under the get OpenAI callback is CB. This will give us our tokens. It's currently giving a warning because we haven't imported it. I just wanted to mention this real quick. Now let's take a look at MapReduce and load QA chain. This is becoming a longer video than I would like to make, but I'm trying to pack as much information as possible. To read in detail about VectorDB or the regular question answering, please take a look at the documentation in the description. So for MapReduce and load QA chain, we may have the necessary imports, and we also have to pip install tick token, which we have done, and we also have to import it. I believe it does get imported automatically with one of these imports from Langchain. Most everything is the same with MapReduce, except we are loading the load QA chain. OpenAI key has to be defined. We are defining a persist directory. Embeddings are OpenAI embeddings. We are doing the exact check to make sure that persist directory exists. We are doing everything the same up until here, and still the same. And except when we are loading our chain, we are loading load QA chain. Defining OpenAI is our LLM. We are setting the chain type to MapReduce, and we are saying return map steps true. You can set this to false if you don't want to see that. If you set this to true, you can print it by results key is intermediate underscore steps right here. Then we are saying while true is only to be able to continuously query the system that we have created. We are using with get OpenAI callbacks because we want to keep track of the tokens used. Then we are asking the user for a query. After that, we are doing a db.similaritySearch query, and we are assigning it to docs. Please remember that our db is what the Chroma either created, including with the embeddings, or that it had loaded. Once we have done our similarity search over the docs, over the database, using the user input, then we are assigning the result to the chain, which we have defined right here, which is our load QA chain. And inputting is a dictionary, the input documents being the docs, which is our similarity return, what is returned from our similarity search. Then the question is in the query, which the user inputted. And then we say return only outputs true. Then we are printing the result, output text key, just to see the result of the answer to our query. We can also print the results of the intermediate steps because we are returning it, if you'd like to examine that. And then we are printing the tokens. You can also customize the prompt for MapReduce. We are not going to get into that, but you can actually find a detailed explanation at the documentation. I will make another video in customizing prompts as well. So this is it for MapReduce. Other than some differences we mentioned, everything else works the same. For Refine, everything is the same. We are still using load QA chain, and all the rest of the code is the same, except when we are defining our chain, we are defining the chain type as refine. And also I have some different print statements. This is printing the intermediate steps. Let me scroll this again. Yeah, like this. We are doing the similarity search outside of the chain because we are using load QA chain. Let's take a look at Map Rerank. This is again the same, as you can see. Everything else is the same, except until when we are loading the QA chain, we set the chain type to Map Rerank. We are again getting the callback tokens. Everything else is the same. We are printing the intermediate steps. You can customize the prompts for both the Refine and Map Rerank. You can read about that in the documentation. So this is it. I will slowly scroll down for every file if you want to copy it from the YouTube video, but I will be putting this for Patreon supporters. Link will be in the description. I hope you enjoyed this video. These are some powerful tools you can use and get summarization and question answering systems running. I hope you found this video useful. Please give it a like and subscribe. Join our Discord server where we discuss these things day in and day out. There are some very cool people who would like to share their information with the rest of the community. And this is it. I think the next video is going to be about how to evaluate different chains. I think I'm excited to make that video as well. Take care and see you in the next video.